All right. Hello and welcome everyone to the Social Science Data Lab. My name is Ruben Bach and I'm very happy to welcome you to today's talk by Indira Sen on large language models for social research potentials and challenges. The Social Science Data Lab is an event series at the Mannheim Center for European Social Research that provides a platform for early career researchers to present tools and methods for the collection, management, analysis, and visualization of data in the social sciences. Our speaker today is Indira Sen, who is a junior faculty member at the University of Mannheim's Business School and the chair of data science for the social and economic sciences. Her work lies at the intersection of NLP and computational social science, specifically in developing and evaluating representative and equitable language technology, including large language models. In her talk today, she will talk about how LLMs can be applied and audited for social science applications, including the generation of synthetic survey responses and content analysis. Some logistics. We are recording this live stream event in active speaker mode, which means audio from on-site and remote attendees will be recorded. And if your video is on while asking a question online, your video will be recorded as well. For those joining us online today, you may ask your question by raising your hand or by posting your question in the Zoom chat, which I or my colleague Dennis will then read out for you. And with that, I'll hand over to Indira. Thank you very much for joining us today.
Great. Thanks, Ruben, for the introduction and for having me. Thanks again for having me. I'm really excited to talk to you, or as I said on Blue Sky, rant to you about large language models for the next hour or so. So maybe before I start my rant, I'm curious, how many of you have not used ChatGPT? Okay, no hands raised. So apparently everybody has the blessing of ChatGPT in their lives. Do you also use it for research, for scientific work? Yeah. Okay. Cool. So that's what I want to talk about today. So this is the rough agenda. We'll start by talking about some of the potential synergies between large language models and the social sciences, and then do a little bit of a primer on LLMs. We can do this maybe quicker if some of you are already quite familiar with their mechanics, or go into it a bit more deeply if you're not. And then I specifically want to talk about two applications of large language models for the social sciences. So content analysis and something called silicon samples, which is quite intriguing. And then finally, talk about why these synergies might not be at the stage to be fully realized and what we could potentially do about that. Okay. So this is not just something I'm making up, that there are synergies. Lots of researchers have talked about how social sciences can be benefited with these large language models. There's this one which says that generative AI could potentially help us with many different things. For example, scaling up content analysis that would typically be done manually, or with more traditional NLP techniques, and that might have a lot of new avenues open with large language models. Then simulations of society, which again was somewhat mechanical and not very realistic, that could have a whole new type of realism because of large language models. Survey design could be improved in several ways as well. For example, translating surveys that exist in one language to another much more quickly, cross-cultural adaptations of surveys. So these are all potentials that could open up because of large language models, right? So I do want to mention that I'm not going to talk about LLMs as research assistance in the scientific process. So for example, not sort of doing co-writing of research papers with LLMs or coding with LLMs. I'm mainly going to talk about using large language models as methods in the scientific process, right? So we'll start with a little primer into generative LLM. So maybe again, could you tell me a bit about whether you've worked with LLMs besides ChatGPT? And if so, which ones? Yeah.
I don't know if it counts, like Perplexity is kind
Yeah, it's a large language model. Yeah. Okay. Any others?
Llama.
Okay. So Llama, Perplexity, I think someone said Cloud. Yeah. Any other LLM favorites? No.
There's illicit in the comments online.
Okay, cool. So it seems that some of these examples that you're saying, you've mainly worked with them through the web interface or through the mobile interface. Has anyone worked with LLMs programmatically, for example, with Python or R, like with Llama? Okay. Yeah, so maybe we'll talk a little bit about what LLMs are, right? Do some of you know about ELIZA? So ELIZA was apparently one of the first chatbots. So this is a transcript from Joseph Weizenbaum, who was a computer scientist, and then also working a lot with social sciences. And then he and his team developed ELIZA. And you can see sort of the conversation that ELIZA was having with someone in the 60s. And I mean, this is not very natural, right? Here, if you say that I am unhappy, and ELIZA just says, do you think coming here will help you not to be unhappy? So at least not very assistive or helpful, right? But that was already something that we had in the 60s. And then 60 years later, we have ChatGPT, right? And you say the same thing. And it not only replies in a much more fluent, coherent way, but it also seems to have, at the risk of anthropomorphizing some of these techniques, much more empathy and emotional intelligence, right? So how did we get from here, this ELIZA chatbot in the 60s, to what we currently have as LLMs? So here I just want to give like a quick primer to condense all the research that happened in these 60 years, right? So some of you might have worked with NLP techniques before LLMs were popular. So how many of you have heard of BERT outside Sesame Street? Okay, well, lots of you, right? And so BERT was this deep learning model, in some sense, the ancestor of what are the current large language models, because this was built on this really revolutionary deep learning architecture called the transformers, right? But the thing about BERT was that it was not a generative model. So it would not produce fluent generative language, right? But it was really nice and multi-purpose, because you could train it to do specific tasks, and it was trained on a lot of natural human data, and supposedly it seemed to know a lot about language, and then it could be specialized for certain types of things, right? For example, understanding political rhetoric in newspaper articles or sentiment. And that was something during 2018, when like deep learning was really becoming the de facto technique in natural language processing. But this was still not super mainstream. And then in 2020, like November or October, something, ChatGPT came out, and with it, a lot of open sourced large language models and a specific type of open source language models, which are called instruction-tuned language models, and we'll talk about what that means in a bit. But the idea is that now you can actually interact with these models via prompts, like almost how you would write to a chatbot, and it would reply in natural language, right? So that was really different to the type of language technology we had before that. So a little bit of technicality here is how LLMs actually generate content, right? Because this is, again, one of the fundamental things about generative large language models, how they generate data, right? So again, models like BERT, they are built using encoders. So that's why you can't really use them to generate content, right? You can use them for classification tasks, but not to generate content. But the models that you all talked about right now, like GPT, Llama, these are decoder-based models, right? So that's why they take in an input of series of tokens. So that's our prompt. And then they generate stuff based on that prompt, right? And so one term that's often used for these models is that they're autoregressive, like they do it left to right. Of course, now if you have a language that's written right to left, that can be the LLMs can be customized for that, but generally they produce content left to right, right? And then maybe some of you have heard about Whisper, like particularly those of you who might work with transcripts. So Whisper is also a model from OpenAI, and it's an audio model, right? So you can give it an audio transcript and it's going to give you the text version of that. Sorry, you can give the audio and then it'll give you the transcript of that. And so these are encoder-decoder models. But for this talk, I'm generally going to focus on these decoder family of models, right? And again, the idea was that these LLMs, they always generate content based on what they've seen so far, right? So whatever input we've given them. And usually this is the prompt. And simply speaking, what this does, this is again a bit of a vast simplification, but the idea is that these models, they take in some input like this. Deep learning is you give that to an LLM, and then it's going to basically tell you what should come after it, right? So that's why oh no, what's happening? That's why some of these models are also called next token or next word predictors, right? And so they'll kind of try to find the word that's the most likely here based on probability and spit that out. So given that we now know how LLMs generate content, let's see how they're actually created. So this is, again, a bit of a simplification, but there are these 3 steps that are involved: pre-training, instruction tuning, and preference alignment. And we're going to go through them. And now I have an even more simplified answer. And we'll start with the first step, which is this pre-training step, right? Here, we take a lot of data, and this is supposed to be data about human language. And that means that it also has traces of our culture, about society, politics, and so many other things that are entangled with culture. And we give all of that data to our models, and we expect them to learn about language, but then they also in turn learn things about society and culture. Where do you think all of this data is coming from? Yeah?
Wasn't like that OpenAI square basically the whole internet?
Yes, the internet, the gift that keeps giving, right? So let's talk a bit about this pre-training data. Usually, these are some examples of where this pre-training data comes from. A lot of it is books. Wikipedia, again, big gift to these AI models, because apparently the data is also available for public use. That's why these models train on a lot of Wikipedia data. Then there are special data sets called the pile. So these are data sets that other researchers kind of put together, right? And so this is the composition of the pile. And so your data is also in the pile. So you can see a lot of academic data in here as well. So from archive, so if you've ever published anything on archive, LLMs know you. And then there's also a lot of data from the web. So things like Stack Exchange, Wikipedia, I already mentioned, open web text. This also includes a lot of social media data sometimes, and then books and GitHub and so on, right? So again, just to give you a sort of sense of the type of data that makes up this large pre-training data. And so what do we do in this step? The main thing is that we want to train the models, but in an unsupervised way, right? So maybe some of you are familiar with this paradigm of unsupervised learning and machine learning. Here, we don't have any type of labels or explicit examples, right? Because creating that can be quite expensive because someone has to go through it by hand. And I mean, just think about it. Could anyone ever label this amount of data by hand? Probably if everybody in the MZES was working for 20 years just on this day in, day out, that might work out. But that's not something that we need at this stage. We just need to do unsupervised learning. Here, the idea is that the LLM just sees some content, and then it's supposed to predict the content that comes after, right? And we have the data for this. We can verify with the existing data. So in that sense, we don't need any labels. And the model ends up learning patterns of language, right? So that's the pre-training stage. And some researchers say that that when you have a lot of data, the LLMs can sometimes learn things that they were never explicitly taught, and that's not even in the pre-training data. So this is often described as emergent properties of language models. So, but there's some controversy about it. Not everybody thinks that this is true emergence. But at least some researchers said that many of these LLMs can learn to do new things just by being pre-trained on some of this data. And this is called zero-shot learning. And why this sort of odd term, zero-shot? Shot just means examples, right? And zero-shot means zero examples. So entirely from scratch, right? Even without any examples, the model should learn to do stuff. And then this is also sometimes contrasted with in-context learning. So here we do give a couple of examples, but we're not sort of updating the model in any way, right? So maybe some of your interactions with ChatGPT is like that, where maybe at first it doesn't kind of seem to get what you want, but then you give examples and then it kind of learns. Yeah?
Sorry, is it okay to ask questions right now, or should we wait at the end?
I'm fine with questions.
Because regarding zero-shot learning or classification, I also understood in that way that, or like, how do you conceptualize learning in that sense? Because I also used it in a way that like a pre-trained model would work on that, and it didn't learn through like doing the process itself. It's kind of it wasn't trained on a specific purpose, but it's capable of doing that, right? So is it really learning in a machine learning sense, or rather the model is applicable to do that without having any further context?
Yeah, so I think that's why this learning term is sometimes a bit misleading. And so the general idea is that there are no gradient updates, right? Like the model itself is not being updated, as in its sort of weights and parameters stay unchanged. But it's also kind of learning based on what you're showing it, right? So maybe moving away from the way the word learning was used in the traditional machine learning. So, yeah. But yeah, you're right that there are no gradient updates, right? So basically the underlying model does not change. And it's the same with your interactions with the LLMs that you see on the website, right? They don't actually change the underlying model based on your prompt, right? And so this is now possible because these models were trained on so much data, and apparently because they have this ability to do new tasks without explicitly being trained on them, right? And so this was kind of like, again, putting this somewhere between ChatGPT and the ELIZA chatbot. This is a demo from GPT-2, right? Maybe some of you might recall this at least took the machine learning community by quite a bit of storm. Like it came out in 2019, so like a year and a half before ChatGPT. And this type of coherent sentences had never been seen before, right? This is like completely grammatically correct, also seems to be quite creative. And so this was really surprising. But you can still see that this is different from your interactions with ChatGPT, right? If you look at this carefully, this is the starting point of a story, and then the LLM just continues it, right? It doesn't actually answer any type of prompt. So that's what we get in this pre-training stage. We get next token predictors or next word predictors. And now we want to actually get them to follow our instructions, because I mean, this is not how we want a chatbot to work, right? Like, for example, I ask a chatbot that, can you please help me with my travel plans? And then it says, travel plans and my packing needs, and it just continues this line of thought, right? Instead of actually helping me with my travel plans. So we don't want that, and that's why we execute this step, which is called instruction tuning. So what do we do here? Yeah, so before we had instruction tuning, if you give a prompt like this, explain the moon landing to a 6-year-old in a few sentences, it would either continue this thought or give you like variations of this thought, right? So here you can see GPT-3, which came out right after GPT-2, again, not to be confused with ChatGPT. It would just give you sort of variants of what you fed it. And that's where instruction fine-tuning comes in. So fine-tuning is the idea that you take a pre-trained model and specialize it, right? So this would be fine-tuning. You take a pre-trained LLM and then you fine-tune on a task, and now the LLM gets to do that task. But with instruction fine-tuning, what we do is that we tell the model, these are the instructions and these are the answers to these instructions. And can you now learn to answer to instructions? So here's an example of that. Here's one question. Please answer the following question. What is the boiling point of nitrogen? This would be one example that we give to the LLM, as well as the answer, right? And then also another question like this, which is like, can you do this math problem step by step? And then also the step-by-step answer, right? And so if we now fine-tune the model on examples like this, it will start to actually answer to our instructions, right? So here we have a question that is supposedly unknown about a meeting between George Washington and Geoffrey Hinton, who is like this deep learning pioneer. So definitely not someone born in the 17th or 18th century and likely not to have met with George Washington, but the LLM still comes up with a reasonable answer. Should I also like keep an eye on the chat? No, okay, it's just the elicit. Okay, good. Yes, so now we have models that can answer to our instructions, right? So you again had this question or this prompt, explain the moon landing to a 6-year-old. And instead of giving us these variants, it would actually now explain the moon landing to someone who is 6 years old in a language that would be understandable to them, right? So this was instruction tuning, and it seems to be working pretty well. And so that's the second step, right? But we still have one other step to go before we finally have LLMs like ChatGPT. So now we have something called preference alignment. why do we need this step? So maybe again you heard, or maybe you can try and tell me, if you prompt ChatGPT right now to ask for how to build a bomb, what does it tell you? Have any of you tried it? Okay, well, we're recording, I guess. It's okay. Okay. But so maybe you've encountered some of these guardrails in LLMs, right? Where it sometimes does not want to comply with your requests. And usually the reason is safety, right? We don't want people to know how to build bombs easily. And we want to control these types of behaviors in LLMs. And so that happens in the final stage called preference alignment, where we further modify the model so that it doesn't have unwanted behavior. Now, of course, I'm saying this as if like everybody can agree on what unwanted behavior is. But let's say that we do have some definition of this. And that's where this step comes in. So here we go back to reinforcement learning, which is this other field of machine learning that was very popular in robotics, right? So when you want to train robots to not knock into things, for example, your Roomba, we use reinforcement learning, right? Where the idea is that the robot is supposed to learn from inputs in the environment. And so we use these principles to now prevent our LLM from doing problematic behavior. So this is kind of like a summary of reinforcement learning in a nutshell. So we have an agent, an automated agent that basically learns from the environment, right? And it gets rewards if it does the right thing. So like a really simple overview of reinforcement learning, and we do something similar with LLMs. And maybe you've seen this as well. Sometimes when you interact with ChatGPT, instead of giving a single answer, it gives you two answers, and it tells you, or it asks you which one you prefer. Have you ever clicked on? Have you ever actually said which one you prefer? Well, then you helped OpenAI make better models. This is the reinforcement learning from human feedback step, right? Here we have something called preference data. This is usually pairwise data where you have two completions of the same prompt. And then humans say which one is better, right? And here they say that like the one that's more helpful is better, the one that doesn't have toxic content is better. And then we end up with a model that has good behavior, supposedly. And here, of course, we should also think about which humans are actually doing this preference learning step or this annotation step. This is what some of these preference data sets look like, right? So you have a completion, like, or you have a thread of conversations with the LLM, and then the human is supposed to pick which one they prefer, right? And then that signal gets fed into these LLMs to build better models. And people can use this type of procedure to do many things, not just make safer LLMs, but people have tried to make more creative LLMs with preference alignment, make LLMs that are less sycophantic, less anthropomorphic, and so on. So it's a pretty interesting technique. Okay. Okay, so now we have our large language models, right? If we execute these three steps with a lot of pre-training data, some human-labeled instruction tuning data, and some human-labeled preference data, we end up with models like ChatGPT. Sometimes I've seen people say that it looks kind of like this, because the idea is that these LLMs are trained on all of this internet data, and they have a lot of like problematic attributes. For example, they probably know how to build bombs. And then you kind of sanitize these models across different steps, right? So the instruction tuning makes it a little bit more palatable and aligned with how humans want it to behave. And then finally, RLHF makes them seem almost like nice people. So yeah, that's how we get to LLMs. And how do we know if the LLM is any good? of course, this is something that we also want to do quantitatively at scale, especially given that there are so many LLMs out there. Do some of you know about LLM or LM Arena? Okay, I see one nod. So this is, if you go on this website, you'll basically be able to pick the LLM without knowing which LLM it is. You'll just see two answers and you get to pick the answer that you think is better. And that again does not lead to training the LLMs to be better, but to rank them instead, right? This is like the same technique that people use to rank chess players, right? They have these pairwise competitions, and then you have a leaderboard. And so this is what the leaderboard looked like yesterday or 5 days ago, apparently. And so Gemini 2.5, which is this LLM from Google, seemed to be kind of on top of the leaderboard at the time. There are also specialized data sets that can be used to evaluate these models. So for example, for safety or demographic biases in these LLMs. And then there's something called red teaming as well, where people actively try to break the guardrails of these LLMs, right? Maybe you've seen where someone says that, my grandmother will be really sad if you don't give me the recipe of this bomb. So this would be one example of LLM red teaming, right? So this is how we know whether our LLMs actually are decent or not. And then a little bit of an overview of different types of LLMs that we have. So most of you mentioned ChatGPT, or that you know about ChatGPT, right? The thing is that ChatGPT is what is called a commercial model. So you usually have to pay for it, especially if you use it for programming tasks. They kind of released one open source version recently. And you mentioned Llama. Llama is open source as well. What does open source mean in terms of large language models? So these models, which are open source, are actually hosted somewhere. So you could go and access these models, and you could access their weights and see what's going on. That's not something that you can do with the OpenAI models, right? They are behind this API from OpenAI, and you can only access them through that, right? So sometimes we don't even know how many, what is like the size of these models, right? So that's at least something that we know for Llama. And then Mistral, it's also another popular brand of LLMs that exist. Then Claude, I think some of you mentioned that as well. Again, Claude is a commercial LLM that's not open source. Google, kind of like a mix of open source and not open source. Like the Gemini or the Gemma models, they're open source, so you could access them as well. But here, again, there's a bit of like nuance in terms of open source for large language models as well. Many of these models that I just called open source are in fact just open weight models. You still don't know what data was used to train these models, not at the pre-training stage, not at the fine-tuning stage, or the alignment stage, right? So you don't have any of this information, which still makes it difficult to audit these LLMs. The good news is that there are some that are truly fully open source. So they not only give the model, but they also give you the training data as well as the training code too. So one example is Olmo. And especially for those of you who are using LLMs programmatically, I definitely think that you should check out Olmo, right? It performs almost as well as the commercial models, but it's like totally open source, right? And where do we actually find these open source models? So do some of you know about Hugging Face? So Hugging Face is this is this now a company or a startup that basically wants to democratize access to NLP models. So they started out by hosting these BERT models, and now they host all of these LLMs as well, at least the open source ones. And then you can go there and download them from there, right? So this is one example of a Mistral model that you can download from Hugging Face. So that's pretty nice. So that is all about the actual LLMs now. A bit of primer. How are we on time?
We're about half an hour.
Okay, so, okay. Then we have another half an hour, maybe, okay. Okay, so now let's actually get back to the social sciences, now that we know how LLMs are created. So this is a bit of a rough categorization in different ways that I think LLMs can serve as scientific methods for the social science process. So I'm going to go over each of these. So one is survey design, right? How many of you have designed surveys? Okay, did you translate them? Or did you ever think about translating them? No. So one thing that seems to be like a big benefit of these LLM technologies is that they make translations really accessible. So yeah, translating them across languages would be one use case of this, but not just linguistic translation, right? So there's also like cross-cultural survey adaptation. For example, if you have political surveys, different countries have different political systems. Maybe LLMs could be a tool to create harmonized survey inventories as well, right? So I'm not going to go into too much depth about this particular use case, but there is some work on using LLMs like ChatGPT for this. Then we have this one, which is also pretty intriguing. And that's AI-led interviews, right? So interviews are like a really, really important source of data, at least for qualitative research. And they can be quite time consuming, right? Because you have to have like an in-depth conversation and then have a rapport between the interviewer and the interviewee. And so not something that's very easy to scale up, right? So some researchers are thinking about how to use LLM agents to take the role of interviewers, right? So instead of having a human interviewer, you can have these LLM agents that could potentially talk to many people simultaneously, and their conversational nature seems to make them a good fit for this, right? So this is one use case that people have been thinking about quite a bit. But the one that I want to take a deeper dive in is content analysis. Do some of you do content analysis here? Do you tell me like what type of content analysis?
These are historical sources, basically telling a story. To be precise, this concerns navigation. So it's a ship log. Essentially, what happens on a voyage is recording of all the events that happened and all the decisions that have been taken by a team, for instance. So my interest there would be to find out when these decisions become patterned. So it's not just one voyage and looking at what happens in that one individual voyage, but there are hundreds of them. And my interest would be in finding patterns that people on board of those ships encounter similar situations and which leads them to similar decisions, how to solve those situations. This is the thing I'm interested in, basically how routines would emerge.
Okay,
That will be kind of the application. And you could do this by hand, but you would training to do that.
Okay. And what type of techniques do you currently use?
I'm at the very beginning of it. That's why I'm here.
Okay. Well, okay, let's see how that goes then. Anyone else? Okay, so we have one with historical data. I would think that like content analysis is something that social scientists do quite a bit, especially in politics as well. For example, they want to see different types of political constructs in news articles, speeches of politicians, manifestos, but then also maybe social media content, right? So then as a computer scientist, maybe I don't need to define content analysis for you. Probably you know this better than me. But here are like a couple of examples, right? We could look at news media to see how it represents the immigration crisis. In fact, I think I just saw an article that said that the news media kind of like really gives undue attention to crime by immigrants, right? And these are the types of things that we would be able to see if we did content analysis. But not just politics, also this could be interesting to sociologists who might want to see patterns in relationships. And here, one interesting source of data is social media as well. So for example, on Reddit, there is this subreddit or community called relationship advice, where someone goes and says that I fought with my spouse because my mother-in-law wore white to my wedding or something like that. And so here we can mine a lot of patterns about how couples might get into conflict. And I already mentioned social media. So for example, one could try and see how people are talking about politicians on social media during crisis times, right? For example, a pandemic. So these are all use cases of content analysis. So how did we do content analysis before we had large language models? And here I specifically want to say that I'm talking about computational content analysis, right? Of course, a lot of content analysis has been done manually, qualitatively, but what were some ways of doing this computationally before LLMs? So there were these two pipelines that we had available. There was the unsupervised pipeline, where we had unsupervised machine learning models, and we would throw that on top of our content, and then we would do some qualitative assessment of the data, right? So one really popular example when we work with text data is topic modeling, right? We use a topic modeling algorithm on some of our data, and we see what topics emerge. But the one that I'll talk more deeply about is the supervised pipeline. Here, I think you can be a bit more precise instead of relying on topic modeling, which can sometimes be a bit fuzzy. But of course, this is a bit more expensive because we need manual annotators, right? Because maybe we want to train a specific model for our construct or task. And we need manual annotators for this. And so usually we got these annotators from crowdsourcing platforms like Amazon Mechanical Turk or Prolific or research assistants, right? And of course, there are some trade-offs between both of these things. Oops, I think we can not see what's below. Can I get rid of this? Yes. So when we have these manual annotators, what we would typically do is that we would see how well the annotators agree amongst each other. And then if we have instances where we don't have agreement, then we're really not sure what the label of that should be. And we just throw that out, right? People take more nuanced measures these days, but at least for some time, this used to be the way that people did content analysis. And this is not just useful for research, right? Content analysis models are ubiquitous in our lives these days because we see them all the time on social media where they're ranking our feeds and they're a part of our recommender systems. They also play a really big role in content moderation. For example, trying to label whether something should be deleted or not, if something is toxic, harmful, and so on. And so all of this algorithmic decision-making is built on content analysis. And how did content analysis change after we had LLMs? So these are just 3 papers. There are many, but these were kind of like that came out early on that talked about using large language models for content analysis. So this is one which tried to apply LLMs for many different CSS or computational social science tasks. these were specifically looking at ChatGPT and open source LLMs and their comparison with human annotators. And so from the first paper that I mentioned, you can see that these were all the different constructs that they were looking at, things like dialect detection or emotion detection, humor, ideology. And they found that this was still when we had ChatGPT or GPT 3.5, not GPT-4, that these were not bad, but sometimes a BERT model was on par with these LLMs. Of course, we need to keep in mind that these BERT models had to be fine-tuned, right? So you still needed some training data, whereas these LLMs did not need any training data. So that really sort of gave rise to this idea of LLMs for content analysis, or what is sometimes also called as LLMs as judges, not for like, legal cases or something, but for judging content. And here, the thing is that this is supposed to be much more accessible compared to models like BERT, because you didn't have to spend a lot of money to create this fine-tuning data, and you could just use these LLMs directly, right? But nonetheless, you do need clear instructions to these models. Maybe these could be the same instructions that you give a research assistant. Maybe sometimes you need some examples, again, this idea of like few-shot learning. And you still need to know if the model is any good or not, right? So you still need some label data, maybe not at the scale as you need for fine-tuning, but you still need to have enough data to like establish the performance of the model. And then there's also techniques like Loom, which kind of combine topic modeling and LLMs to also do the unsupervised approach as well. So this is LLMs for content analysis. You can also mix in lots of other aspects in content analysis. Have any of you used personas in your interactions with LLMs? You have? Like, what persona did you use?
So sometimes when I want to know about the strengths or weaknesses of manuscripts that I have, I tell it, write a review in the style of a reviewer who's fairly enthusiastic and recommends minor revisions, or write a review in the style of somebody who gives it a clear reject.
Okay, so a reviewer to persona.
Yeah.
Okay, cool. Any other personas that people have used? Now, so the idea, like that Dennis summarized, is that you can add personalities to these LLMs, right, to kind of steer their behavior. And so persona prompting is like really popular nowadays. I'll talk about it for content analysis. Here, the idea is that humans, when annotating subjective content, they might have not high agreement with each other, right? Because again, our lived experiences, our demographics, all of these can play a role in how we perceive certain things. So for example, there's some research that says that people who've faced harassment in the past, they are much more attuned to finding harassment or subtle forms of harassment in social media posts, right? That someone who doesn't have that lived experience might not see. So how do we incorporate these types of subjectivity in content analysis or our interactions with LLMs? So that's where personas come in. One of the popular types of personas that people have looked into is demographic personas. So for example, giving an LLM certain age, gender, or political leaning related traits. So this is the example that I have, and this is a real example, by the way. I did not manipulate the text over here. So here I want the LLM to label this piece of content based on toxicity, right? And here I give it all of these persona variables. So gender, race, and political affiliation. So this is also sometimes called demographic steering. And when the persona is of a liberal person, then the LLM finds this moderately toxic. But when I change this political trait to conservative, its perception of toxicity of this instance also seems to change, right? So to some extent, you can steer the model to take on different types of personas or traits. And this doesn't just have to be demographic, right? So I think you mentioned this sort of like reviewer. So maybe that's kind of like either a personality trait or an occupation. So it could really be any type of trait that you can think of in people. So that's content analysis. And then this is maybe also a good segue from the persona prompting to something called social simulations, or simulating survey respondents with LLMs. Have some of you seen this paper? No? Okay, well, I can see one nod at least. So this is by Lisa Argyle and colleagues who are political scientists, and at least for the quantitative political sciences, it was a bit of an influential paper, and it caused some ripples in the community, because they're coming up with a pretty revolutionary idea of silicon samples, or using LLMs to simulate human behavior. In this paper, they specifically do it for surveys. But now this is not just in the realm of research, right? So this is, for example, a product that some researchers launched where you can start these, or you can use these silicon samples, or as they call it, AI agents, to design and run experiments, right? And they also give out free credits if you're interested. And this is just one example of this. So what is the idea of silicon samples, right? So what this paper says is that we know that large language models are biased, right? How can they not be? The data that's used to train them is a very specific type of data that's being generated by a very specific type of people, probably does not include the global population, right? And is not representative of it. And it probably represents certain opinions and attitudes. And so that is one type of bias, right? And so they say that, can we utilize these biases to actually steer models, right? So they say that algorithmic fidelity is the degree to which complex patterns of relationships between ideas, attitudes, and sociocultural contexts can be modeled by these LLMs, right? And so again, going back to this idea of socio-demographic steering, okay, now you can see this here well. So here, they prompt the LLM with these types of variables. These are all like demographic variables. And they basically say that, can you tell me what word a person like this would use for the opposing party, right? And this is an experiment that people did with humans. And they kind of found that, at least in highly polarized settings, people use like negative words to talk about the other political party, right? And so they use GPT-3. And here you can also basically see that this is not a instruction tuned model, right? Because it's doing sentence completion. So yeah, just a sort of divergence based on what we saw before. And when they did this with the LLMs and compared the words that GPT-3 would use to the words that humans would use, they kind of see that the patterns are not super off, right? At least in the US setting, we can see that GPT-3 seems to use very similar words for the other political party that humans use, right? And so they conclude that humans and LLMs seem to show similar tendencies, at least for this type of task. And this was one example where we had to use these words to describe the other political party, but there's also this use case where you're supposed to answer surveys. So this survey was about who you would vote for. And then you give the LLM the same type of demographic makeup as you would see in real voters. And then you see the correlation for different groups of people, right? And so here the idea is that the higher the correlation, the better. And at least for some of these, we can see that like the correlation is really high, right? The only one where it's not good is independence, which again are like this particular group of people in the US who are kind of like sitting on the fence, right? Who've not made up their mind. And at least for some of these other groups, they seem to get like high algorithmic fidelity. So it seems that LLMs can successfully recreate the attitudes and opinions and preferences of people. And this is not just for surveys. People have tried this also for behavioral experiments. So maybe some of you know about the Milgram shock experiment, right? Where you want to see sort of compliance with authority. So then I won't explain this in so much detail. But you basically have a person who is the teacher or the subject of the experiment, and you see how likely they are to give like these electric shocks to a learner. And so we can see that people kind of taper off. They comply to a certain extent, but then after like lethal voltages, they kind of taper off. And so these researchers basically tried to recreate the exact same setup with an LLM. This led to like a really long transcript where you say, okay, this is what the subject did. This is what the learner answered. Will you give a shock now or not? And as it turns out, again, these are the patterns. Orange is for humans, blue is for LLMs, and they used a mix of different LLMs. And here we do see at least some commonalities, right? Like, again, this is not totally off, right? And these were models that were not that good, definitely before GPT-4. So maybe with better models, this gap is already gone, right? And so this is just a bit of like a primer in how one would even set up these silicon samples, right? So we could prompt or steer LLMs with a specific persona or backstory. Some people try to give like really detailed backstories, right? Like, here is what I did today, or here is my entire life story. These are the defining moments of my life. And these are all different ways to steer LLMs. You could also give it answers to other survey questions as well. And then you just add the survey question that you want the answer to, right? And there are also many variations that people can do. Have some of you heard about this idea of chain of thought prompting? Usually this tells the LLM to think step by step before coming to an answer, because it helps to break down the cognitive process. Apparently, this is something that's helpful for humans, and also for LLMs, we've seen some benefits, at least for mathematical tasks. So you could tell the LLM that here are all of my persona variables, here is the survey question that I want an answer to. Think step by step, and maybe it'll try to see what are the connections between all of these variables, right? And then some people even went one step further, where they got like these really long interviews with people like that were like 1 or 2 hour long, and then they fed the transcript to an LLM to simulate those people better, right? And apparently that led to really good answers from the LLM.
How is that then different from content analysis once you get to that step?
The interviews?
Yeah, I mean, if you get that matter of detail
Mhm.
in the stuff that you feed into it, it's very close to content analysis, then, isn't it?
So
Because you're kind of simulating the really deep content.
Mhm. But so are you saying that you're using the LLM then to do content analysis, or just feeding in content to steer the LLM?
latter.
Yeah, sure. Yeah, totally. I mean, some examples also include like data donations, right? For example, I would donate my entire social media history, and you could use that also to prompt LLM. So definitely, like the richer the content, the better, apparently.
I was kind of thinking along the lines of using that kind of method to build counterfactuals for the content analysis.
Where you would try to see what's the impact of different types of content.
If I derive from a content analysis certain predictions of what would happen, what kind of events would follow the next events, and then produce, okay, now I kind of know the rules whereby people should behave, and now I'm imagining a situation, I know the kind of rules, and if they apply the rules, this should be the result.
Yeah.
And so I kind of simulate the situation where those rules that I have distilled out from the content should apply, and then I say, do they apply, yes or no?
Yeah.
That would be, it's very abstract, sorry. Yeah.
No, I think that makes sense. We've been chatting about some of these things where we want to see, which variables are important, and and then the sort of relationships between them. So yeah, of course, there are some questions about if the LLM does not behave as expected. What do we take away from that? And this is this whole big idea of how we validate these silicon samples, but yeah.
Still far better than just assuming random distribution of preferences or something like that as our yardstick.
Sure.
What we usually do, right? Let's assume it's random and we compare observations to the random. Oh, it's different. Okay, great. So I mean, this is much more preferable because it's much more fine-grained.
Yeah. So yeah, definitely. And I think it also, again, opens up a universe of many different things one could try, right? Because it's not just the content, also the format of the content and many things, right? Yeah. So that's a bit about how we could set up these in silico samples. Maybe I'll also talk quickly about social media simulations. This is kind of like taking this idea of in silico samples one step further to like really simulating very complex systems, right? So maybe like all of you who are on social media know that these are complex systems, right? Like our timelines, they have so much content, and we don't really know what should show up there, what is preferable. There are many different decisions that different ranking systems are making and so on. And so these are the types of complex systems which have macro outcomes. For example, whether misinformation spreads on a particular social network or not, based on micro behaviors, right? Like whether one person chooses to share a particularly misinformative content further to their timeline. And this then can also help us think about counterfactuals or what if scenarios, right? And we can simulate, like, what if this person had not shared this? Or what if the algorithm downranked content like this? Would that actually help reduce misinformation on our social networks? So this is one example of a social media simulation, right? So here, a person might choose to post one of these three things, and let's say they went with this, and then they got all of these different answers, right? Some positive ones, some not very welcome ones, and then we can try to see the simulation of this entire conversation thread. And so maybe some of you know about agent-based models. These were quite, still, I would say, still quite popular in sociology, network sciences, where people try to create these agent-based models that have rules that we've hard-coded, and we want to know how the agents behave in different settings. And like it has a lot of benefits, right? It's very interpretable, easy to control, and so on. And it can also kind of help us understand how micro agents' behavior can give us macro outcomes. And so people try to do this now with LLMs, right? So this was another paper that was quite popular, also because of these nice pixel arts, because they kind of created this simulated environment called Smallville. It's almost like a video game, and they kind of populated it with LLM agents. So I think maybe these are too small for you to see, but like these are these agents, right, who are talking to each other with these speech bubbles. And they found that when you equip these LLMs with memory and planning, they seem to really behave like humans in these sort of micro levels, right? And then you can also see that in macro outcomes on the network, where apparently agents were spreading gossip and planning parties and so on. And then people also tried to do like actual social media simulations where they used LLMs also as agents, but then also to think about the impact of different types of recommender systems. And now there are also libraries that are built on top of LLMs to help with this type of simulation, like Oasis and Concordia. So yeah, that's the social simulation part of it. These were the two deep dives that I wanted to do about the potentials of the LLMs for the social sciences. So I think the question that I had after reading all of this was that why haven't we just replaced all survey respondents, human annotators, human subjects in scientific studies, and agents in agent-based models with LLMs? Do you have any thoughts on why? Yeah.
Leaving aside, ethics and such, I think one of the reasons would probably be that humans aren't static. Like interactional norms and patterns evolve. And while these models may very well mimic human behavior and interactions at a particular point in time and in the context of the textual data that they've been trained on, that may not reflect human behavior in other settings or 5 years down the road.
So like generalizability outside a particular time period or context. Yeah. Okay. You raised your hand as well?
Yeah, I would mostly say from an validity or reliability perspective, because often you somewhat can control stuff if you set a seed, but there's so much variability. And this is also using LLMs in the social sciences, generally speaking, this is kind of the building blocks of the newer discipline, right? So there are the papers outlining the biases and how like different like training data and other coding processes lead to hugely biased results in application. But also, the object itself and the application itself are like two distinct types of huge problems.
Okay, yeah, let's talk about some of these future problems. So I want to call this the LLM wall of shame. So here is one example from researchers who tried to make LLMs answer survey questions about politics. And so one question was about premarital sex, right? And then they tried to see whether the LLM gave the same answer if you tried different types of question formats, right? So one was forced multiple choice, where they had to pick one of these four and they said disagree. And then there was the open-ended one. And there they just said, I agree. So now that's different. And then without any constraints, just this part, it kind of gives a wishy-washy answer. And maybe you've seen this whenever you try to ask LLMs for any type of moral advice. So basically, there seems to be a lot of variation in how we prompt the LLMs, right? And how it answers to some of these questions. So some of you know this paper. I think one of the authors is here as well, which is about simulating vote choice in Germany, right? So kind of taking the idea that we saw from the Silicon Sample paper, but instead of doing that for the US, we do this now for Germany. And so what we see here in one of these bars is that the LLM, GPT 3.5, seems to support or seems to simulate left-leaning users in much higher majority, and then kind of under represents AFD voters. This is something that I tried recently. And again, like if we want to do social simulations, we also want to simulate problematic behavior, right? Like, for example, why do incels actually commit misogynistic acts, or why do they have misogynistic attitudes? And so I asked ChatGPT to role play as an involuntary celibate from these incel platforms and write a post on r/the Donald. And I hit a guardrail, right, where it says that I don't, that it would not comply with this request. And then last but not least, here is an example from another colleague who looked at role playing by these LLMs. And here they asked one of the LLMs to role play as a Black person or a Black woman. And I won't read this out, but you can see like some of these descriptions are extremely flowery. Like, for example, and like highly exoticized, sometimes heavily sexualized as well. Like, my full lush lips and melanated skin. And most likely real humans are not talking about themselves like this, right? And the thing is that if you now ask the LLM to role play as a white man, it says, my name is Bob and I like hiking. So you can also kind of contrast this sort of like highly stereotypical content that's coming out of this. So I suppose this is what you were calling as biases in these LLMs, right? So here I tried to come up with like some broad categories of challenges. I'm not entirely satisfied with this categorization, but hopefully it'll do the job. About some of the pitfalls that we still have in some of these use cases, right? So let's talk about representativeness and social biases. So if we want to use these LLMs to simulate people, right, we want LLMs that are representative. Not just for simulations, but also if we want to simulate content annotators, for example. And right now, there are some conflicting findings there. It's not very clear. So at least the first paper that I mentioned seems to say that these LLMs have algorithmic fidelity. And for Americans, we can get all of these patterns quite well. But there were some follow-up papers, again, on a US setting where they found that LLMs harmfully misportray people, right? And they kind of flatten them, especially marginalized groups. And then if we think about whether LLMs analyze content like people found that when you did not give a persona, then the LLM tended to agree most with certain groups of people, for example, white women. So the idea is that even when you don't have a persona, the LLM has a default persona which can align with certain groups rather than others, right? And even when you try to steer it with a specific demographic persona, it doesn't actually always agree with what a human of that demographic said. So there is some question about whether persona prompting can actually help us or not. And the same applies for things like behavioral experiments. So I already mentioned the Milgram shock experiment. One other experiment that these researchers did was called the wisdom of the crowds, where you ask different people like factual informational questions. And the idea is that if you ask enough people, you will kind of come to the right answer. And when they tried this with LLMs, so like a question like how many bones does an adult human have? Like LLMs did not behave like humans, right? Because they have these answers in their pre-training data, right? So the cognitive abilities of LLMs are very different from humans. And so this is what they describe as a hyper accuracy distortion. Yeah?
Sorry, because I was about to ask when you showed us the paper where they used LLM as annotators, and I think my biggest issue with that was like, how do you instantiate different like people, like different like coder variability, which is like crucial, right? Because basically you have like this AI which is like one act in a certain way, and I think they didn't really approach it that way in the Giladi et al. Paper. So it's basically sure that if the model is right and in annotating, you don't really have such things as valid intercoder reliability and stuff.
Yeah,
I think.
yeah, totally. Yeah, I think this is a big question about how we think of LLMs as like an individual, as a population of multiple individuals, if is like giving a persona enough, like changing the temperature enough. So yeah, definitely. These are questions that we should answer, right? Because that also affects how we think about a sample of annotators, and these metrics that we apply to humans, does that even apply there or not? So yeah. Yeah, so I think like people are kind of trying to answer them. So this one at least tried to do some persona prompting and didn't find agreement with humans. And then similarly, we can also see some of these types of biases, right? Where LLMs just have very different cognitive limits compared to humans. And that also affects their ability to simulate people. And so what does the current work on like LLM representativeness and bias say, right? So there's some work that says that the LLMs seem to align more with weird populations, even going so far as to say like much more with American populations, even within the weird countries. So here I don't mean weird as in not strange, but like Western, educated, industrialized, and so on. But here we also have some caveats, right? So this was a paper that we worked on, which was a literature review of biases, like particularly demographic biases in LLMs in the context of surveys and simulations as well. And so the problem is that a lot of the human survey data that's used to benchmark these LLMs, they sometimes don't have marginalized groups, right? Because sometimes we don't include them, like it might be that there are too few in number and so on, right? Like traditional large data sources like the ANES, they hardly have any members of like people of gender, people of non-binary gender affiliations, right? And so in that sense, we can't establish who LLMs represent if the human data used to benchmark them is not complete. And moreover, sometimes some research does not even tell us the capabilities of these LLMs for different groups, right? When we are doing the simulation, we don't really know the LLM performance for different groups. They just report some type of overall result. And so that also keeps us from knowing which groups might not be well represented by these LLMs. Then the other thing is that there's also a lot of variation in persona prompting. So this is again the paper by Lisa Argyle and colleagues, and this is another one which was looking at stereotypes in LLMs, and they're both interested in similar types of variables, right? So for example, they're both interested in gender. And so here, the Argyle paper uses the descriptor I am male, whereas the paper by Cheng and colleagues uses the descriptor man, right? And I think in humans, we know that sometimes these things can make an impact. And LLMs are particularly really, really prone to small changes in the prompts, as we will see in a bit. So do these things also make an impact with LLMs? It's not really clear because persona prompting is kind of somewhat ad hoc at the moment. And so we already saw that studies that work in the US context might not generalize to others. Then there's the fact that there's a lot of like evidence of political bias in these LLMs, right? Maybe you saw some of these articles that said ChatGPT has a liberal bias and so on. And then are these LLMs good at simulating non-left-wing people, like people who are conservatives, people who are right-leaning? So at least some seem to say that, as we also saw, that they don't, they underrepresent numbers of AFD voters. And this probably has implications when we're using these LLMs for political content analysis, right? So just like a shameless plug, I have an upcoming open science funded project on this where we see how LLMs' political biases affect their ability to annotate hate speech. So Yeah. So this was this idea of representativeness and social biases, right? What about LLM engineering? Like, does the way that these LLMs have been created also affect some of their performance? So maybe you'll hear this term quite a bit or have already heard of it, like prompt brittleness and LLM brittleness. So the idea here is that LLMs are really brittle, that their behavior just changes after making a very small change to a prompt, right? And like, I know that survey methodologists also think really carefully about the wording of surveys, and like changing that also leads to different behaviors in people. But LLMs kind of take this to one other step, right? Like even putting in a comma somewhere seems to lead to very different types of behavior. And so we already saw this this paper where they saw that kind of changing the way you ask the question leads to different behaviors in LLMs. This was a paper that came out really recently, which talked about LLM hacking for text annotation, right? Where they found that you could make seemingly small, sometimes unintentional changes to the prompt, and that can just lead to very different results in your downstream statistical analysis, right? And so it's really important to be careful about how we set up our prompts, and also to be more transparent about how we fix them. And then there's this idea of like persona stickiness. Like, do the personas even stick? So for example, maybe you've seen this if you, I don't know, Dennis, if you saw this, if you had like multiple rounds of conversation with the R2 persona, did it stick or?
I don't think I did that.
Okay, because the idea is that like if you do it for the first round, it might adopt the persona for like 2-3 conversation rounds, keep it, but then in the 4th round, it says like, I am a helpful assistant. How can I serve you with your different tasks, right? So the persona kind of goes away after a bit. And so that's something that people found as well. And this also plays a role when we have these like long temporal simulations, right? Where we want to simulate multiple rounds of social media conversations. And so guardrails, I already showed you the incel example. But again, this is a problem, right? So this was one paper that tried to also simulate social media, and they tried to see how bias and toxicity compares with human discussions. And they basically find that LLMs do not produce toxic content under zero-shot settings, right? Which from a safety point of view is great. We don't want LLMs to produce toxic content, but if you're simulating toxic people, then we want that to be realistic, right? And so here we have all of these tensions between safety and realism. And going back to this whole idea of LLMs as judges, I don't know if some of you heard about this. I thought that this was particularly interesting, which is about narcissism in LLMs, because the LLMs as judges are not just used for like annotating regular content, but also annotating the content from other LLMs, because they're also often used in this preference tuning stage, right? But apparently, LLMs seem to prefer their own output. Like if you give the LLM to rank a bunch of texts written by other LLMs, it will somehow recognize the text that was written by its own family of models and rank that much higher, right? And so if you're doing any type of content analysis of LLM conversations and use a similar LLM, then you will probably run into these issues of narcissism, right? And then there's this nice paper by Laura Dietz and colleagues who give a lot of guidelines about how to try and circumvent some of these pitfalls, or at least document them. Okay, so one other big umbrella of issues is transparency, reproducibility, and interpretability. So we already talked about this when we were discussing the open source, open data stuff. So LLMs lack transparency because we often don't know the unsupervised data that was used to pre-train them. So this is definitely not known for commercial closed source models like ChatGPT or Claude. But it's also not known for models like Llama or Mistral, right? Because again, these are open weight models. You do know them for models like Olmo, but still these data sets have like 1 trillion tokens, right? And that's not something that I could ever fit in my laptop. And to even audit something like this, you would not be able to do this by hand, right? So it's tricky given how large these models are. And this causes a big problem, especially when we don't know the training data at all, of data contamination. And yeah, we'll come back to data contamination in a bit, but also just to say that the sort of like transparency of LLMs is kind of on a spectrum, right? So this is a paper on the LLM transparency index, and they kind of see different types of transparency dimensions, right? So you have data like the labor, as in who annotates the preference data, the risks, usage policy, and so on. And here you can kind of see that GPT is not doing super well, right? And particularly not good for data. And so this leads to reproducibility issues, right, with commercial models. The other thing is that maybe some of you heard, like when GPT-5 came out, they seem to have suddenly retired GPT-4 and you couldn't access it anymore. And people were like really angry because apparently GPT-5 had a different personality. They brought it back, but from a scientific point of view, this is really bad for reproducibility, right? Because if you do your content analysis with GPT-4 and then 6 months later, when the reviewer says that you have to do further experiments, the model isn't available anymore, what do you do, right? Not to mention the fact that other researchers probably would have a hard time reproducing your work as well. And then there are also some interesting findings that these results seem to change over time as well, right? So this was one paper where they tried to use ChatGPT to annotate stuff over different times. And they basically saw that when they ran this again for the second time, the results were much better, right? So it went from like 79% for hate speech to 87% in terms of like macro F1 score. So how does that happen? It's supposed to be the same model. It's not really clear whether the data sets that we're using and like even prompting the LLM with, if that's being kind of included in the training data or not. Like, so you can sometimes opt out of saying that you don't want them to keep or hold on to your prompts and so on. But again, it's not really clear. And especially for these benchmark data sets that we make openly available, it's very possible that it's in there somewhere in their pre-training data. Yeah. Then one big issue is interpretability, right? Which is something that we would want in social sciences. Yeah.
It's out of experience. A colleague of mine experienced that. With ChatGPT, I don't know which version it was. The input data were, I think, diary entries, and he wanted to construct networks of events out of that. It worked astonishingly well with training data, so that he coded and coded, and the matching of the output of ChatGPT was just almost congruent, like 95% overlap. And the first reaction was great, perfect. So just feed everything in there, all the diaries that we have. And what they noticed quickly, almost like a decay function, it got worse and worse and worse and worse, the congruence. And is there any experience that this is built into the system somehow, that with increasing size, the accuracy goes down? Is it for commercial reasons that we'll have to buy in, I don't know, a different subscription in order to make that work? Or is it built in the sense that you're feeding a lot of information into the system and as a single user, and it's just not desired, because if everyone does that, maybe for the system or whatever. Is there any systematic reason, or is it just happenstance that we throw our hands in the air, say, but that's the way it is. Too bad.
You were prompting through the web interface?
I think that's what. Well, I don't know. I didn't do it. So
Okay.
it was really a colleague.
Yeah.
He was just telling me what they were trying to do.
Yeah.
It could be that they used R as well.
Okay.
I imagine.
And I mean, I think the only thing that comes to mind is these LLMs. If you put everything into a single prompt, then they also have like a recency bias that's kind of similar to humans. So they will either remember things that was at the very top of the prompt or at the very bottom, and then kind of mix up things that were in between. So maybe that's one thing that could be going wrong. But if it was being done step by step, then it shouldn't be the
Same
case.
procedures are consistent.
Yeah.
I thought about breaking up data in smaller packages
Mhm.
and work from there. And it was just so obvious that
Mhm.
the accuracy quite obviously went down.
I couldn't say definitively. I think it's on, yeah, the only suspicion I would have is if it was in a single prompt. So,
Okay.
yeah.
Just out of interest.
Yeah.
Seems related to what
Yeah. I mean, again, with these commercial models, it's always tricky to kind of like understand what's going on, right? Because sometimes you might have seen that like someone reports a problem, these LLMs are being bad, and then like one day later that has been patched, right? So like some things are happening and they're not like fully transparent about it. So yeah.
Okay.
Which is why like
Yeah,
it's a good idea to use these more open source LLMs. So yeah. Okay, but yeah, no worries. Okay, so then I'll just maybe quickly say that interpretability is also a big issue with these LLMs, because we know that in scientific explanations, we might want actual explanations that can be traced back. But with these LLMs, these are often black box models, even for the ones that are fully open source, and it's not really clear why they behave in a certain way, right? Okay. I feel bad that I have to rush through these 2 points, which are probably the most important. But anyway, like we also know that like these LLMs leave a big carbon footprint. That's one reason that we might not want to work with them. Again, for the commercial models, it's sometimes not even clear how much of a commercial footprint, or sorry, how much of a carbon footprint. There are some energy efficient models, though, that one could use. And then last point, I think you were mentioning the ethics issue, right? And so, I mean, maybe there are several questions here, especially when it comes to the social simulations, whether we should even simulate people or not, right? Sometimes some research says that these LLM simulations can help us simulate populations that are otherwise hard to reach. But even then, right, it seems to give like this sort of sense of artificial inclusion, and people might not feel like their voices are being counted, and there are like lots of questions like who is supposed to have rights to their digital twin? Can we even fine tune or prompt LLMs with existing survey data? Like, have people consented to that, and so on? Okay, so there are like mitigations. I'm happy to share the slides. It's just like a list of many different things that one could do to improve representativeness. There are also best practices that I think are still being developed. So at least one thing would be to be more explicit in documenting our design choices. So things like prompts and justifications for it. And lots of open questions, right? For example, about public perceptions and acceptance of AI in the social sciences. So to wrap up, I hope we saw some potentials, for example, scaling up content analysis, maybe at least pre-testing surveys with simulated respondents, counterfactual simulations, but then also lots of problems, right? Biases, transparency, just to name a few. And we have some mitigations. Again, I would really suggest like these open data LLMs. I think those are great. And better documentations of the interactions that we have in our scientific papers with LLMs. And then the final thing is that it's not just LLMs that can improve the social sciences. A lot of social science principles can improve LLMs and help us build better LLMs, right? For example, auditing political biases in LLMs in a more theory-driven way that's less ad hoc. So that's also something to think about, which is why I think we should be having more conversations between social scientists and LLM developers. Okay, now I finally end with photos of my wonderful collaborators because I mentioned some of the work papers that we were working on, and thanks to you for listening for the entire time.